This is the video to introduce the Integrity Validation Tool for Evidence, which is one of the components of the MEDINA framework. The video is organized in 4 different parts. First, an overview of the tool. Then, I will show how to use it, including a quick demonstration. Next, we will dedicate some minutes to the installation of the tool. And finally, some pointers for further reading about MEDINA. Let's start with the introduction. To put in context, MEDINA project aims to provide a framework of tools and techniques supporting the continuous audit-based certification of cloud services in the UCS standard. The Integrity Validation of Evidence is one of the many tools developed in MEDINA for making the audit-based certification more secure and trustworthy. The Integrity Validation PF Evidence refers to the MEDINA Evidence Trustworthiness System component, whose main objective is to maintain an audit trail of MEDINA evidence and assessment results to guarantee their integrity and be able to detect if this information has been tampered. This tool provides 2 different ways of operation. On the one side, it provides a manual way to verify the stored information about MEDINA evidences and assessment results. On the other side, it also provides an automatic verification tool to easily and quickly detect if current evidence and assessment results, stored in the orchestrator, are the same as those previously recorded in the trustworthiness system. For this functionalities, the MEDINA Evidence Trustworthiness System component is based on blockchain technology, which enhances the security level of the solution in the following way. It provides a record of information on a verifiable and permanent way by design, as blockchain guarantees that stored information cannot be modified. By this way, information integrity, traceability and verification are guaranteed. For providing these functionalities, the MEDINA Trustworthiness System has the following features. 1. It provides 2 different user-friendly graphical interfaces for improving usability. There is one Kibana-based dashboard for accessing all the stored information about evidence and assessment results, and a second user interface for the automatic verification of the current evidence and assessment results integrity. 2. The tool provides security by design thanks to the use of blockchain as backbone. Integrity and transparency are guaranteed. 3. The tool includes a blockchain client which exposes a REST API for an easy provision and retrieval of information. By this way, blockchain technology is transparent for the users. 4. Sensitive information is not stored in the blockchain due to confidentiality and privacy issues, as information recorded on the blockchain can never be removed. Instead, evidence and assessment hashes are recorded to be able to detect information tampering without disclosing sensitive details. 5. Finally, the tool has been implemented in a way that it is easy to be extended in terms of information to be recorded in addition to evidences and assessment results. This is how the trustworthiness system fits inside the MEDINA architecture. It receives evidence and assessment results information from the orchestrator as input and provides integrity validations to auditors or compliance managers as output. Well, here you can see the list of components the trustworthiness system interacts with. It refers to the information I have just explained in the MEDINA architecture. The trustworthiness system receives evidence and assessment results values from the orchestrator and provides integrity validations of this information in a graphical way to compliance managers and auditors. Now, let's enter in more detail in how this component can be used. This is the architecture of the trustworthiness system, in which the different subcomponents can be seen. The backbone that I have mentioned several times, which acts as secure storage, is the blockchain network in which some smart contracts have been developed. A blockchain client which exposes a REST API is used to interact with the blockchain in an easy way. This interaction can be directly from other components from the automatic verification service, which provides automatic integrity checks of evidences and assessment results. Furthermore, the information recorded on the blockchain is also accessible through the blockchain viewer, which provides a Kibana-based dashboard for users. Let's now see what functionalities each subcomponent provides. A common blockchain network for different cloud service providers has been deployed in MEDINA. It maintains a secure and cryptographically linked audit trail of evidences and assessment results from different CSPs. In MEDINA, a distributed quorum network has been considered. Over this blockchain network, Some smart contracts have been deployed for the evidence and assessment results audit trail storage functionality. The storage is secured because the smart contract's execution is secure and it automatically runs when a predefined conditions are met. Although the blockchain network is common for all CSPs, each CSP needs a blockchain client to interact with the blockchain in a transparent way as it internally deals with all technical details required for interacting with blockchain. As mentioned before, EAR exposes a REST API, as the one you can see on the slide, for easy interaction. The next component is the blockchain viewer, which has been designed for showing all the information stored in the blockchain for the different CSPs about their evidences and assessment result. This is the manual way auditors have to access the recorded information and manually verify it. As you can see on the image, it is a Kibana-based dashboard in which the complete list of evidence and assessment results is shown for each CSP. Let's see now demo of this manual access to the recorded information on the blockchain.
Okay, let's start then with the manual verification demo. Well, here you can see the blockchain viewer based on Kibana, based on Elastic. This is the URL to access this blockchain viewer. And while here, an auditor or a general user can see all the information recorded on the trustworthiness system about pieces of evidence and about assessment results. Well, at the top of the dashboard, we can see the total number of pieces of evidence and the total number of assessment results that have been recorded on the trustworthiness system, that have been recorded on the blockchain. Then we have a list or a table of registered pieces of evidences, and for each evidence, what we record is the evidence ID. This is the identifier inside MEDINA for the piece of evidence. We also record the evidence hash. Instead of recording the evidence value, we only record the hash. Why? Because in many cases, the value of the evidence is considered confidential, and using hashes, we avoid disclosing confidential or sensitive information while allowing to prove the integrity of this information. So that is why we considered only the evidence hash inside the blockchain. And apart from that, we also record some associated information to evidences that can be considered useful for auditors. We record also the associated resource. We also record the evidence collector the evidence has been gathered from. We also record the associated cloud service ID the evidence refers to, and then when the information has been received from the orchestrator and when the information has been recorded on the blockchain. Something similar happens with the assessment results. We have a complete list of the recorded assessment results on the blockchain. Here we can see the assessment ID, which identifies the specific assessment result inside MEDINA. Following the same approach with evidences, we only record the assessment result hash instead of recording the specific value of the assessment result, and we also record some useful information for auditors, such as the metric, also the associated evidence that refers to the ones previously recorded, and the same information, the timestamp when the information has been gathered from the orchestrator, and the timestamp when the information has been recorded on the blockchain. So here you have the complete list. Many information has been recorded, the same about the evidences, and an auditor can access in a manual way all the pieces of evidence and all the assessment results that have been recorded on the trustworthiness system. For usability purposes, we have also included some specific filters for evidences, and something similar happens with assessment results. For instance, if we want to look for a specific evidence, we only need to apply this filter, for instance. Let's wait. and we will find the information related to this specific evidence ID. In the same way, if we only want to look for evidences related to a specific resource, we can apply the following filter, and we will obtain the list of evidences, of recorded evidences that has this associated resource. Let's remove all the filters.
Now, we see the last subcomponent of the trustworthiness system. This is the automatic verification service for automatic integrity validation of the current evidence and assessment results from the orchestrator. As you see in the figure, it provides a complete list of all the evidence or assessment results currently available on the orchestrator, identifying if its value has not been tampered, which should be the usual case, or a problem is detected, maybe because of a change on the information or because the information was not previously recorded on the blockchain for any reason. Let's see now a demo of this automatic integrity verification system.
Okay, let's start with the second demo related to the automatic verification service. For accessing this service, we need to go to the integrated UI of the MEDINA framework. This is the integrated UI, and we need to sign in. Let's use, for instance, the admin user, signing in. And well, once the user has been authenticated, we need to go to the integrity validation of evidence section, and here we have the different options for this tool. Well, starting with the first one, the list of evidence, this section will provide a complete integrity validation of the pieces of evidence recorded on the orchestrator, currently recorded on the orchestrator. The idea is to, well, let's make a submission and let's see what happens, but the idea is to make an automatic comparison between the current value of evidence recorded on the orchestrator in comparison with the value previously recorded on the blockchain. Here we have the list of evidences and, well, the evidence ID and the integrity check. If a green tick appears, that means that the integrity is correct, the evidence has not been tampered in the orchestrator, and the evidence value recorded on the blockchain is the same one as the current value on the orchestrator. Also referring to hashes, as we only compare hashes, not the value directly, because of the confidentiality issues we have mentioned before. Well, here we have the complete list. All the evidences are in green, but maybe we can find one incorrect comparison. For instance, here. In this case, the evidence ID, well, the integrity check of this specific evidence ID is shown as incorrect. Well, let's try to see what happens. I have copied this evidence ID, and the idea is to go to the second section to make a specific evidence ID integrity verification. Let's paste the value. Okay, let's make the submission, and here we can see what happens. This is the hash based on the information currently recorded on the blockchain, and the problem is not that the information has been tampered on the blockchain. The problem is that for any reason the information was not previously recorded on the blockchain, so the integrity verification is not correct because we cannot compare it with previously recorded information. Why should this happen? Maybe because the trustworthiness system was down at some point, or there was a problem, but well, we can identify that this specific evidence ID cannot be considered secure enough in terms of integrity. Well, something similar happens with the list of assessment results. We can make a submission to obtain the current integrity validation status of the currently available assessment results on the orchestrator, and the idea is the same. If we obtain a green tick, that means that the assessment result has not been tampered, but if we obtain a red cross, it means, for instance, that some problem has happened. Maybe the assessment results has been tampered, or maybe the trustworthiness system didn't work at some point. We can detect that the assessment result cannot be considered secure enough in terms of integrity. Let's validate in this case this specific assessment result. Let's make it a specific submission, and as you can see, the information related to this specific assessment result cannot be found on the trustworthiness system. And well, the last thing I wanted to show you is that for both cases, we can apply different filters to obtain only the evidences and assessment results related to a specific cloud service ID or a specific tool ID in the case of the evidences, and also for a specific cloud service ID or metric ID in the case of assessment results. We can also filter for the good compliance assessment results.
Next, we will give some technical details about the component and explain how to install it. Let's start with the blockchain network and the already deployed smart contracts. They are provided as a service from Technalia infrastructure. This network is automatically accessible through the blockchain client without needing to configure anything. The blockchain client needs to be locally deployed to be able to interact with the blockchain network and the smart contracts. It is a Docker image that needs to be run locally. Here, you can see the steps that need to be followed for pull and run the Docker image from the MEDINA artifact. An account is needed in advance as login is required. If you follow the steps, the blockchain will be accessible at the indicated URL. Next, we have the blockchain viewer. In this case, again, it is also provided as a service from Technalia as it is common to all CSPs. Here you can see the URL to access it. Finally, we have the automatic verification service, composed by a front-end and a back-end Docker images that, equally to the blockchain client, need to be locally deployed. For this purpose, the same process as with the blockchain client needs to be followed. The Docker images need to be pulled from the MEDINA artifact for a posterior local run. If you follow the steps, the blockchain will be accessible at the indicated URL. Here you can see a list of technologies that have been used within the MEDINA evidence trustworthiness system. Hyperledger Quorum is a selected blockchain technology. The smart contracts have been developed in Solidity. The blockchain viewer is based on Elastic Technologies. The automatic verification service has been developed in React and Node, while the blockchain client has been developed in JavaScript. Finally, Docker has been considered for easy installation. This is all about the trustworthiness system. However, if you are still interested in more details about this component, or about MEDINA in general, here you have some interesting pointers. If you need more details about the component presented so far, or about the MEDINA project in general, you can visit the official webpage on the first link, where you will also find all public deliverables of the project. Project-related videos, such as demos or training videos, are also available in the MEDINA YouTube channel. The third link points to the MEDINA community in Zenodo, where among other things, the papers produced during the project are available. Finally, the source code of the project is available at the last link, in the MEDINA GitLab. And that was it. Thank you and goodbye.